morning, students. This is Saima Khan, and I am taking digital system subject. And this subject belongs to computer science engineering student of third semester. In previous presentation, we have discussed about the combinational circuit, and today we are going to explain the next topic of combinational circuit, that is half adder circuit. Before To understand half adder circuit, let us discuss about binary adder. Addition is one of the most basic operation performed by different electronic devices like computers, calculators, etc. The electronic circuit that performs the addition of two or more numbers, more specifically binary numbers, is called as adder. Since the logic circuits use binary number system to perform the operation, hence the adder is referred to as binary adder. So, depending on the number of bits that the circuit can add, adders or binary adders are of two types. They are half adder and full adder. So, half adder is a combinational logic circuit which is designed to add two binary digits. The half adder provides the output along with the carry value if any generated. The half adder circuit is designed by connecting an exclusive OR gate and one AND gate. It has two input terminals and two output terminals for sum and carry. The block diagram and circuit diagram of the half adder is shown below. And if we see the block diagram of the half adder circuit, we found that we have two inputs A and B and their corresponding two output S and C, where S is used to store sum and C is used to store carry. Whereas in the circuit diagram, two gates are available. One is exclusive OR gate and other is AND gate. With the help of exclusive OR gate, we can get the sum, and with the help of AND gate, we have carry. From the logic circuit diagram of half adder, it is clear that A and B are the two input bits, S is the output sum, and C is the output carry bit. In case of a half adder, the output of the exclusive OR gate is the sum of two bits and output of the AND gate is the carry. Although the carry obtained is in one addition will not be forwarded in the next addition. Because of this, it is known as half adder. Means that in any case, half adder circuit is can add only two bits and not more than this. And the operation of the half adder were run as follows. Half adder adds two binary digits according to the rules of the binary additions, and these rules are as: if we add 0 and 0, we'll get the sum 0 and carry 0. If I add 0 and 1, I'll get sum 1 carry 0. Likewise, if I add 1 and 0, we have sum 1 and carry 0. And if I add 1 and 1, in this case I'll get the sum 0 and carry 1. According to these rules of binary addition, we can see that the first three operation produces a sum whose length is one digit, whereas in the case of last operation 1 and 1, the sum consists of two digits. Here MSB, most significant bit of this result, is called a carry, which is 1, and the LSB, least significant bit, is called the sum, which is 0. Now after working operation of this, we have to design truth table of a half adder circuit. And truth table is one that gives the relationship between inputs and output of a logic circuit and explain the operation of the circuit. Following is the truth table of the half adder. So for designing truth table, we must have number of inputs and outputs. In the table we have two inputs A and B, so we have to write all the possible binary combination that are 00, 01, 10 and 11, where S and sum are the output result generated with the help of binary rules. If I add 0 and 0, I'll get the sum 0 and carry 0. If I add 0 and 1, I'll get the sum 1 and carry 0. If I add 1 and 0, the sum is 1, carry is 0. If I add 1 and 1, sum is 0 and carry is 1. So we have tabulated all this result in the truth table. After designing the truth table, we have to find expression for sum and carry. For this, we have to use K-map or Karnaugh map. We can use the K-map method for simplifying Boolean algebra to determine equation of the sum bits and output carry bits of the half adder circuit. The K-map for half adder circuit is shown. We have to design individually K-map for the sum as well as for carry. For the sum, first design 4-column K-map for the sum and 4-column K-map for the carry. Then put all the values of zeros and 1 from the truth table. After this, try to group the ones, all the number of ones, and we can see that we have to take all the ones singly, individually. There is because there is no possibility of grouping any one. Then after this, we have to find expression, that is S is equals to A complement B plus AB complement, and likewise C is equals to A dot B. Then we have to write characteristic equation of half adder. The characteristic equation of half adder, that is the equation of sum and carry, are obtained according to the rules of the binary addition. These equations are given below. The sum S of the half adder is the exclusive OR of A and B. The sum S is equals to A exclusive B, or S is equals to A B complement plus A complement B. The carry C of the half adder is the AND gate of A and B. Therefore, carry C is equals to A dot B. The application of the half adders are some of the important application of the half adders were as follow. Half adder is used in arithmetic logic unit ALU of computer processor to add binary bits. Half adder is used to realize full adder circuit. Half adder is used in calculators. Half adder is used to calculate addresses and tables. At the end, if I conclude half adder, then from the above discussion, we can conclude that half adder are one of the basic arithmetic circuits used in different electronic devices to perform addition of two binary digits. The major drawback of a half adder is that it cannot add the carry obtained from the addition of the previous stage. That is, a half adder is not able to add more than 2 bits. So as to overcome this drawback, full adder circuits are used in the electronic circuit. So students, in the next presentation, we'll learn about the full adder circuit and how the drawback of the full half adder circuit is overcome by using full adder. This is all for this presentation. Thank you students. Thank you so much.